Okay, so now that I've described the procedure for mapping a regular expression to the language that it's describing, let's see an example of how you would actually go through this procedure. So suppose I have the regular expression AB star plus B star, and I want to know what language is described by this regular expression. Okay, so intuitively, what should be the strings that match this regular expression based on how we've been talking about regular expressions so far? Well, if the string matches this pattern, it either matches this pattern or this pattern. If it matches this pattern, then it has any number of B's. And if it matches this pattern, then it starts with an A and then has any number of B's. So let's see if we apply the recursive procedure, whether this sort of comes out or comes through. So I apply L to AB star plus B star, and I get, as a result, the union of L AB star with L B star. Okay. So I have this step. Now I break this down again. I split this up because I have a concatenation here. So I get L of A concat, now this is a language concatenation, L of B star. And again, I take the union, but now I'm going to take this star operator out. So it's going to go from a regular expression operator to now a language operator. So now this is now the star operator applied to L of B. Okay. And then again, I'm going to do the same thing, but now this time for B star. So I get L of B whole star, with this star as the language operator. And now I'm ready to convert, right? So essentially what I've done is I've reduced my regular expression down to its atomic regular expressions. So I only have symbols in this case. And so that means that I can now map directly to languages. So L of A is the language containing the string A. L of B is the language containing B. Then I apply the star operator to it. And then again, L of B is the language containing B, the string B, and then I apply the star operator to it. Okay. And so we see that, well, if we think about language operators now, what this is telling me, it's telling me that this language is the language that concatenates the language with only the string A with the language containing any number of B's, right? And so effectively what that is, that language is ABN for n greater or equal to 0. And then in the same way, B, the language just containing B whole star, that maps to the language just containing a sequence of B's any number of times, and so I can rewrite that as Bn for n greater or equal to 0. Okay, good. I am not quite sure. Oh, right, okay. I think someone had asked also about the precedence of the star versus the concatenation. So just to make this clear again, in terms of order precedence, if I have A, B star, then this maps to applying the star only to B, right? So this would not be A, B whole star. To do that, you actually have to write it out explicitly. Okay, so now this is the sort of formal mechanical procedure to get from a regular expression to a explicit representation of the language that it describes. But usually you don't really have to go through all this trouble. And once you get familiar enough with regular expressions, you can typically write down the explicit language quite quickly. So for instance, an exercise I gave in class was, if I have the alphabet AB, what are the languages described by each of these two regular expressions? Well, for this one here, I have a plus, so that definitely means I need a union for my language. And then I have a union between the language described by A star and the language described by B star, but that's any number of A's, any number of times, and any number of B's, right? So I guess saying any number of B's, any number of times is redundant, but you get what I'm saying. It's a sequence of B's any number of times, right? Now, on the other hand, if I have A plus B whole star, well, this maps to the strings that match this regular expression are strings that at every position either have an A or B, and this also includes the empty string. And so that means that really A or B star is matching any string that can be formed using the alphabet AB. So L of A plus B whole star is just sigma star. And so what that shows us that in general, if I have a regular expression, if I have two regular expressions, and I join them together with the plus, and I apply the star operator to that, then this is not necessarily going to be equivalent to R1 star plus R2 star, meaning that the star isn't going to distribute over the plus operator. And so this is the formal way of talking about regular expressions which are not equivalent. And so actually I didn't write this in the notes, but formally if you have R1, or I didn't write this during the lecture, but formally if you have R1 and R2, which are regular expressions, then you'd say that R1 and R2 are equivalent if and only if they describe the same exact language, right? And so we see that in this case, this regular expression is not equivalent to this regular expression because, for instance, we have this counterexample. And it turns out that Stephen Kleene proved this in his Kleene algebra. So he developed this whole algebraic field in which he started with a bunch of axioms, I think like 10 or 15. And he showed that if you have any true equivalence between two regular expressions, then you can always prove it using the axioms of his algebra, of the Kleene algebra. And so that was a very impressive result at the time. And to be honest, I still think it's impressive. That's pretty cool, I think. Okay, so I think, let me keep going. Let me finish this exercise and then I'll start a new video. Yeah, okay, let's do that. So this exercise, I think, might help you for one of your assignment questions. And so in this case, I have the alphabet AB, and what I'd like to do is I'd like to design a regular expression R for which the language described by R is the set of strings of the alphabet AB, for which every A and W is followed by at least one B. Okay. So another way of saying this is in my string W, whenever I have an A, then I must have a B. Okay. And so what are the strings that should be described by this regular expression? Well, for instance, I have this long-ish string. It has a bunch of B's, then it has an A, and then immediately it has a B. That's required. Again, it has another A, and then immediately it has a B, and then optionally it has this extra B. Another type of string that should be described by this regular expression is if you don't have any A's, right? So this was the case that you had at least one A, but if you don't have any A's, then that still satisfies this definition here, because this is kind of like an implication. It's saying that if the string W has an A, then it's immediately followed, so immediately followed by at least one B. Maybe I should have written that, not used the, okay. And so because this is an implication, if the premise of that implication is false, right, meaning that I don't have any A's, then the whole implication is still true. And so that's why BBB would still satisfy this definition and therefore should be described or should match the regular expression. But an example of a string which shouldn't match the regular expression is something like BBBA, because now I do have an A, but it's not followed by B. So then that means that I can kind of split this up into two cases. The first case is if I don't have any A's. Well, if I don't have any A's, then that means my string is any number of B's, right? And so we know that that's exactly B star. If instead I do have A's, right? If instead I have at least one A, then I might have some b's to start with, then at some point I'm going to have an a, and once I have an a, I immediately need to have a b, and then I can have some extra b's that follow. And that means that, and then this pattern can be repeated any number of times, right? Well then, let's write that down as a regular expression. That's going to be, you can start with any number of b's, and those are optional. And then once you do have an a, then you must have a b, and then you can have some extra optional b's, right? And then that pattern can repeat any number of times, which is why I have a star here. And so now that means that I can join these two things together, right? These are the two cases because they're cases that are exhaustive. I can just take their disjunction and that should be a valid regular expression. Well, it's already a valid regular expression. I mean that it should be a correct regular expression. And so that would be in this case b star or b star, ab, b star whole star. Right? And hopefully, if you look at this for a few seconds, you'll notice that this b star is actually redundant, right? This b star is matching strings with only b's, but I can also match strings with only b's using this pattern, because I could just say, let me deactivate or turn off this pattern. I'm allowed to do this because this has a star. Then I only activate this pattern b star, and so then I can match strings with any number of b's. And so then this is an equivalent regular expression.